Okay, ladies, gents, good morning. So you had the equally likely dice challenge. So just interesting little math activity. Hopefully you enjoyed trying it. Originally, this came to me working on a Mathify shift, and a student came and asked about it. And the idea being you still get the same outcomes as normal dice when you roll them and add them, lowest being 2, highest being 12, but then there's an equal number of everything from 2 to 12. And some of you asked, well, aren't they already equally likely? And originally, that's what I thought too when I first tried it. But then, when you go and you start by making one of these tables to show all the outcomes, you notice you get 1, 2 from 1 plus 1, you get 1, 12 from 6 plus 6, and then you get 6 sevens going diagonally across. So, only one of those and only one of those, and then 6 of these. So 7's very much the most likely one to get. So then the idea is redesign what's on the 6 sides of the dice, each cube, to get numbers from 2 to 12 to be equally likely. Now, some of you did notice that if you take the numbers 2 to 12 and divide by the 36 spaces, there's not an equal number of spots. You end up with 3 extra. So it does involve a little bit of lateral thinking to try to figure it out. So here's what I tried to do. Okay. So one dice I left the same, 1, 2, 3, 4, 5, 6. The other one I did 1, 1, 1, and 6, 6, 6. So then that gave me 3 2s, 3 3s, 3 8s, 11s, 12s. That's all good. The only problem was I still, as we're chatting about before, 3 extra spaces, and they ended up being 7s. So I didn't want those there. So what I decided to do was make the 6s on that one dice red and the 1 on the other dice red. So then I just said, okay, I don't want those 7s there. So if you roll dice and you get a red on one and a red on the other to make a red 7, it doesn't count and you have to re-roll. That way, I'm just eliminating those choices. So then there's an equally likely chance of getting anything from 2 to 12 because the red ones don't count. So, it is changing the way we use dice, but it still solves the problem. Now, over the years, I've seen about 6 different ways of solving this, designed by students. This is the way that I came up with, but I'd still love to see other people's solutions. So if you continue on with this challenge and you come up with a solution, let me know. I'd love to repost it and share it with everybody. Okay, thanks. Bye for now.